So first of all, hello everyone. Good morning. Dear authors and invited guests, welcome to the technical session 7D. My name is Siddhi Auti and I'll be your moderator for today's session. So if you face any issue, you can write it to me in the chat box. Me, on the behalf of the Global Knowledge Research Foundation and GIA Scholarship, it is my great pleasure to welcome you all to the 9th International Conference on Information and Communication Technology for Sustainable Development, ICT4SD. The ninth edition of the conference is being organized in a hybrid mode. The physical event is organized today in Goa, and the virtual event is being held via Zoom meeting on 8th and 9th August. I hope you will all enjoy this knowledgeable and interactive session throughout the day. In this session, in total, we will be having 10 presentations, and each presenter will be given a time span of 8 minutes. And 2 minutes will be kept for question and answers. On 7 minutes, I will be raising a reminder. And also, there is another request for all the presenters that you stay connected with us till the very end, till the closing remarks. And if you have any query update, you can write it to me in the chat box. Now, just before we get started, I would want to introduce you all to the today's session chair, Dr. Kirit J. Modi. Professor Kirit J. Modi is currently working as a professor and head at C and IT department, IQAC coordinator at Sakalchand Patel College of Engineering, and dean at Faculty of Computer Science, Sakalchand Patel University. He has more than 20 years of teaching experience. He has published more than 25 research papers in the reputed international conference referred journals. He has served as a member of editorial board and program committees of international conferences and journals indexed in Web of Science Scopus. I welcome you, sir, to today's session. Now we will proceed with the presentations. So the very first presenter we have here today is Gayatri Bhoyar ma'am, and the paper she'll be presenting on is a study of on smart greenhouse monitoring system using Blink IoT application.
Uh, Good morning, everyone. My name is Gayatri Bhoyar, student of MCA at DMHR DU, Varda, presenting in 9th edition ICT4SD. Topic for presentation is a study on smart greenhouse monitoring system using Blink IoT app, and the paper ID is 437. These are the content that we can see in this presentation. Let's start with the introduction first. Monitoring and regulating greenhouse environmental parameter manually are a time-consuming and labor-intensive process. Utilizing a smart greenhouse system to automate this procedure can substantially reduce labor cost and increase crop yield. Additionally, a smart greenhouse system utilizing Blink IoT app provide ability to remotely monitor and regulate greenhouse, allowing producers to manage multiple greenhouse simultaneously. Therefore, the purpose of this study is to investigate the potential advantage of smart greenhouse system utilizing Blink IoT app and evaluate its efficiency in optimizing plant growth. Literature review. Smart plant monitoring system using Blink application. The research describe a system using Blink for remote monitoring of temperature, humidity, atmosphere pressure, and soil moisture for plant health. Second, IoT-based greenhouse monitoring system with disease detection. The work proposed an IoT system with additional layer of image processing for disease detection in greenhouse using unspecified IoT platform. Third, integrated approach for smart greenhouse monitoring using machine learning. The paper explored the combining sensor data with machine learning to predict and optimize environmental condition, likely using a customer software platform. Fourth, smart greenhouse monitoring system for sustainable agriculture. This paper focus on sustainability. This research emphasize efficient water management through a sensor-based irrigation system, likely controlled by generic IoT platform. Fifth, design and implementation of low-cost smart greenhouse system. Cost effectiveness is a key aspect of this work, proposing low-cost smart green system with functionalities like remote monitoring and control, likely using a generic IoT platform. Research gap. Here are 5 research gaps for smart greenhouse monitoring system using Blink IT application, advanced sensor integration, limited research on integrating advanced sensors such as soil nutrient sensor, pest detection system, and the plant health monitor with Blink to enhance environmental monitoring, scalability and large scale deployment need for studies on scalability of being placed system for large commercial greenhouse, data analysis and AI integration, insufficient exploration of integration, advanced data analytics and AI for predictive maintenance, crop yield prediction, and automated decision making within the Blink based system, energy efficiency, lack of research focus on optimizing energy consumption of IoT device in greenhouse, interoperability and security gaps in ensuring seamless interoperability with IoT platform and protocol, and insufficient analysis of security measures like data encryption and secure communication within the Blink based system, need of the system. Traditional greenhouse, while effective, require constant monitoring and manual adjustment to maintain the ideal growth condition. This can be time-consuming, labor-intensive, and prone to human error. Here is where smart greenhouse system with Blink comes in. Precise control. Sensor provide real-time data, allowing system to automatically adjust the factors like humidity, ventilation for optimal plant growth. Remote monitoring. Being smartphone app allow growers to monitor condition for anywhere, enabling faster response to potential issue, resource optimization, automated irrigation based on soil moisture data ensure plant receive the right amount of water, minimizing waste, reduce labor cost, automation minimize the need for content manual adjustment, freezing up time and resource, improper plant health, consistent and optimal growth condition lead to healthier plant, potentially increase yield and reduce disease risk, early problem detection, real-time data allows for easy identification of potential problem before they significantly impact the plant. Objective of research, real-time monitoring, remote control and automation, user-friendly Blink interface, resource optimization and scalability of the scalability and adaptability research method. The system is equipped with wide variety of sensors that will assist farmer in automation in greenhouse to more effectively monitor and control condition as it required. It features sensor for both temperature and humidity so that the farmer can keep track the condition within greenhouse. It is equipped with soil moisture sensor that can determine the level of moisture of soil. The buzzer will go out if there is a fire in greenhouse because it is equipped with flame sensor that will alert farmer to situation. It comes with light dependence register module which can measure the amount of light intensity in greenhouse. All of the sensor data may be viewed on 60 by 2 LD display through the Blink IoT or mobile app. In addition, there is a fan and light and humidifier and motor content within the system. This component may be manually activated using the switch or they may be activated remotely using the Blinker mobile app by selecting the manual option. This is a user interface of the Blink application. Conclusion. This research successfully developed a smart greenhouse monitoring system utilizing a Blink IoT app. The system efficiently integrates various environmental sensors to monitor critical parameters like temperature, humidity, soil moisture, and light intensity. By leveraging the Blink IoT interface, user gain real-time access to sensor data and enabling informed decision making regarding to the greenhouse management. These are the references. I referred 20 paper. Based on that, I have mentioned the 5 papers. Thank you.
Jalpesh Versa, sir,
Yes, ma'am.
would you be able to present right now?
Yes, ma'am.
Okay, so we can proceed with your presentation. The paper title he's presenting on will be Guarding Privacy in Federal Learning, Exploring Threat Landscapes and Countermeasures with Case Studies. Sir, I'll stop sharing my screen, then you'll be able to present.
Yes, ma'am. Just a second. So, good morning, everyone. My name is Jalpesh Fosa, and I'm from the Charodhar University of Science and Technology from India. And today I'm going to present a paper entitled Guarding the Privacy in Federated Learning, Exploring the Threat Landscapes and Countermeasures with the Case Study. Today's agenda of this discussion is related to currently the industry is moving towards the AI arena, and there is a bit more you can say that about thinking about privacy, right? So, and we can even see some of the advertisement on the TV, like by Apple and other things, that your privacy is very much necessary. Okay, so the federated learning, and so today's agenda is discussing about the one of the technique that is used to preserve your privacy is by using a federated learning. Then we are just going to start with the architecture of that, and which are the vulnerabilities that is right now present in the federated learning and different types of attacks, then the literature survey, and how to do the attack and what is the mitigation techniques for that. Okay, and lastly we just discuss the future directions and the research challenges. Now, first of all, what is federated learning? So, and it is considered as to be the decentralized machine learning paradigm. So, normally the people are worried about their data, right? So, when your data has been collected without your knowledge and other things, and you already know that for the machine learning to train a model, that there is a huge data requirement will be there. So, when you collect any data, you must need to take some permission or to some users that your privacy of that particular user should not get violated, or you just need to give that particular confirmation to the user, right? So, in that centralized approach, centralized machine learning, we need to collect the data on a single machine and then we have to train our model. But in the decentralized machine learning, we do not need to share our data to the particular data collector or the particular company. Instead, the particular company will send a model to the user's device or end device. The model has been trained on the user's device, or and the trained model has been sent back to the server. Okay, so when we are doing a collaborative training on decentralized data, so the first approach has been used with the local model training. So model has been trained on our own devices instead of sending the data to the server. So data will not be collected by these data collector companies or the service provider companies. So local model has been trained on our machine. Then it is also considered the privacy sensitive approach because we are not sharing our data. Second, privacy and security has also been provided by using the data localization. So data will locals remains in our same devices. It does not leave our data. It does not leave our devices. And it will also been compliance with some of the laws like GDPR, HIPAA, and other things. Okay, privacy laws in the different countries like European countries and American countries, and even in India, right? So that privacy compliance has also been provided by this method, federated learning. And this method has also some advantages over some traditional methods, like we are doing some decentralized training, and it reduces the communication cost because instead of sending the data, might be data will be in bulk, like 1,000 GB, 2,000 GB. Instead of sending the data and getting back the that particular data, we are just sending a model and get back the model. Okay, so communication cost has been reduced significantly. And we are also enhancing the privacy of the data because any provider company does not collect the data. Now, the basic architecture of this federated learning will work in the way like there is one server is there, and the server will have some initial model. The initial model is being sent to different devices like the device 1, device 2, device 3, and up to n devices. The model will be trained. That model has been trained by the server, has been trained on the that particular different devices, and the particular different devices send that model back up to some certain intervals to the server. What server will do? Server will just fetch all the models that is trained on the different devices. It will aggregate those model, and the model weight has been updated. So when the model weight has been updated, again the new model has been sent to all other devices, and again this process has been repeated multiple times. So you will get the better, you can say that prediction and other things. Okay, so we are just doing there is some decentralized architecture, so data is distributed. So not all the data is remaining the single devices, and no centralized data on a single server. So that privacy leak or privacy breach will be eliminated. There is a central server is there, and there is also local device training will be there. So independent training. So one device is not dependent on the another device, or one device's data does not depend on the another device's data. So independent training will be there, and we can achieve some privacy and security. Now, there are still some few vulnerabilities when we are adopting the practices for the federated learning. So there are basically three different types of risks are there. One is the privacy risk, another is the security risk, and the third one is the decentralization challenges. So in the data privacy risk, it will be leakage, might be from the model updates. Let's say we have did, send the model 1, and after few updates, we are sending some model 2. So people can identify, yeah, what is the difference between model 1 and model 2, and they can change accordingly. Okay. So even with without the raw data, and updates can reveal some sensitive information. And also there is a possible of some inference attacks are there, like membership inference attack, model inversion attack, or poison attack, or something like that. Okay, so that we will discuss later on. Then there are also some security threats are there. So like civil attacks. So might be from the genuine devices, some attacker will add some fake devices to manipulate your training data. And backdoor attacks. So some hidden functionality has been introduced to compromise the model. So these are the security threats. And so decentralization challenges are there, that there is a limited control. You cannot control the end user's device, right? So difficult to monitor the data quality and prevent the malicious action. Then also there is a non-malicious failures, like your model has been sent by the server but does not received by the server, does not received by the end devices. So non-malicious failure. And data heterogeneity, like maybe you can't control the data has been trained, your model has been trained on which type of data. So this data heterogeneity will also be the challenges. Basically, we are focusing on the privacy challenges or privacy attacks in federated learning. So there are poisoning attacks, free rider attacks, CIA threat attacks, and inference attacks are there. So we are mostly focusing on the inference attack and poisoning attack over here. So these are the list of different types of attacks on the federated learning. And these are the attacks should be possible in the while we are doing the federated learning. Now, the literature survey has been done by all of the authors of this paper, and we have just identified few of these topmost paper, like published in latest scenario 2023 and 2022. And we have just find some challenges, okay, and there are some research gap is also there. Like in some of the papers, we have find that there are a comprehensive survey of these challenges and applications, but emerging attack trends and future research direction is missing. Then there is also taxonomy of FL threats, attacks, and defenses, but some advanced defense techniques and attacks involving emerging technologies has been missing. Okay, so these are the literature survey that we have did. And after that, we have identified the three different use cases in which different attacks has been done, and we have done some practical analysis on how to mitigate those risks. Okay. First case study is about first case study is about data poisoning attack in healthcare data. So for that, we just need to demonstrate the impact of data poisoning on model integrity using the healthcare data, because you don't have control over the end user in federated learning. So might be one user is training your model with some good data, and might be some attacker will train the same model with some malicious data. So means there is some poison, they are adding some poison to the data, means malicious data. So the attack process is that contains the attributes like this. Then initial model training is there, and then some poison has been added to your data. Means data will be corrupted. Corrupted in sense we are adding some noise to our data. So 10% of training data randomly selected, and we are adding some noise, or we are changing some label as well. So might be it will get misinterpreted or misclassified. Okay, and the outcome is compromised model integrity, right? So might be our model will get compromised due to this addition of this noise and other things. So here some sample of these data set has been provided over here. And these all these three data set in our experimental purpose has been taken from the Kaggle itself. Now the another case study we have taken up on this is for the membership inference attack, and it is for the financial data. So in the membership inference attack is basically used to infer the training data on the machine learning model, right? Because
Sir,
yes, ma'am.
sorry for the interruption. There's 2 more minutes left
Okay.
for the present.
Okay. So this model is basically used to infer the model, and these are the data set that we have used. Another third case study is a model inversion attack, in which you attacker wants to flip the model, means how the actual model and what is their constructed model, and they want to find the similarity. So these are the three case studies we have did, and we have just used these three different types of attack. When our model is under the normal state, we are achieving the 92% accuracy. For the financial data, we are achieving 96, and for the purchase data, we are achieving 85% accuracy. When we are doing a attack, okay, so let's say data poisoning attack, the accuracy is reduced up to 78%. Then membership inference attack has been done, the accuracy is reduced up to 83%. And when we use some defense mechanism, so there are some defense mechanisms are there, like outlier detection for the data poisoning. So if we do the outlier detection, we can restore our accuracy up to 89%. We cannot restore up to full 92%, but we can restore up to 89%. And we, for that purpose, we have used logistic regression model. For the membership inference, we have used differential privacy defense mechanism, and we can achieve up to 95% of which is only 1% less than the actual the normal set scenario. And for that, we have used the random forest model. And for the model inversion, we have just used noise injection and model regularization defense mechanism, and we can achieve up to 82% compared to the 85% in the original one. And for that, we have used CNN model. This is the comparison analysis of different types of attacks under the normal state, under the attack state, and under the defense mechanism we have used. Accuracy under the defense mechanism we have used. So we can say that our defense mechanism is pretty much achieve the near about original state accuracy. So these are the future directions and research challenges that we can just do in this federated learning domain. And these are the conclusions like we just need to offer a comprehensive analysis of attacks and defense strategies. And we are just aims to support the secure and ethical growth of federated learning and data-driven world. So these are the different references. And last three are the data set that we have used that is taken from the Kaggle. And thank you, everyone. Thank you, sir.
Bhaskar Sai sir, I think you have joined the meeting. Now you can present with your paper.
So it will combine of models used. Uh, it's like a combination set of modules built together for reviewing of car data set. Like for example, if a company A wants to analyze how the products work in the market based on real-time data, like the reviews that people give in websites. So we collect those data from websites like Auto BHP and etc. And we did the web scraping for that. And based on that data set we have created, we use Veda. So uh, calculates the score of a sentence, whether it's a negative or positive based on its vocabulary. So as a first step, we calculated the reviews that we scraped from web using that Vadar model. And later on, we started to build our own model based on LSTM and BERT. Basically, for BERT, we used BERT for encoding the words that we did. And then later, to train the model LSTM, we used our own dataset, which was scraped and later tagged using Vadar. We inputted that dataset into this model and prepared our own model based on BERT and LSTM. So this model will usually categorize the data review into highly positive, positive, negative, and highly negative and neutral into 5 categories. So after categorizing the reviews, it will rank all the for each segment of car. It will rank whether how this particular car is working in the market based on the real-time reviews. And upon out of all the cars they have, will rank them based on their ranking score, which was summarized using these scores. Usually it's called a Silhouette score. And once that is done, we also have clustering. Like inside each car, particular categories like performance, comfort level, etc. For them also, we have from each review, we pick up those words specifically. And based on that, same scoring will be used for internal parts as well. So this helps in understanding how a particular car is performing in a market and how the internal systems have been reviewed by customers in real time. So we are currently developed the model and it's currently running, and we are trying to integrate some external applications like to understand it in a more in-depth way. So yeah, so these currently polarity score we use Vader, and then for sentiment analysis we built a BERT, and then visualization can be seen. This is the architecture of our project. And we got around 80s percent.
Thank you, sir, for your presentation. Now we will proceed to the next presenter. In the meanwhile, Sir, if you could just give us a review about the paper titles today and just say a few words about it.
Yeah, so I would like to good morning to all, and I would like to congratulate to the authors who presented the work, right? So I have seen that the first author, so I think Gayatri, so she has presented about the how the link that IoT concept can be applied for the greenhouse monitoring. So yeah, so she has presented the contents in a very proper way, and yeah, there is a need to explore the things in a real environment. I think she has presented the things in a simulated environment, but we can even think that okay, how we can apply in a real test bed scenario, right? Regarding this, the topic, I think the Jalpesh has presented about the federated learning. So I think in terms of the literature and the other aspect, the concept is, I think, not explored much. So the topic is good, and now there is a need to even review all the aspects, right? Okay, how one is, of course, the security. In addition to that, how we can make the federated learning more effective, and how we can create that kind of the awareness among the people about this topic concept. So there is a need to think about that, because now people are focusing on, or they are even gradually they are now associated with the online learning and this kind of the federated learning concept. So there is a need to develop a kind of the secure and stable the framework, and we can say model for that, right? I think regarding these one topic which is presented by the author, and he presented something about how we can apply the machine learning technique for the automobile industry, right? So she presented about the certain machine learning techniques for that, but I think the things presented in a very short duration, so I couldn't able to even give some more insights. But yeah, he presented, and he tried very well about how to apply the, we can say, the machine learning techniques, AI techniques for the uh, automobile industry and for the brand positioning. So yeah, so in that way, the good attempt has been done. So again, I congratulate to all the authors who presented their work, and next time we expect that they can even uh, do some more insights on that. They even provide some more the in-depth, we can say, outcome on the topics on which they are working. So with these words, I again congratulate to the all the authors and the organizing team of this conference for this nice arrangement. Yeah.
Thank you, sir. Thank you
Thank
so much for your insights and giving me to how to proceed further, sir. Thank you so much, sir.
Thank you, sir, for your valuable insights. Now, unfortunately, most of the presenters are absent, and we can't wait anymore. We have to proceed to the closing remarks. So I'll just start with those. Okay, so I sincerely thank our authors for their excellent presentations and contributions in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on the behalf of the whole team, thank you for the support during the ninth version and all the previous 8 versions of this conference. We will be happy to see you in the 10th version in 2025. All the presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have already been forwarded to the Springer. The publication will be live within 6 months. So kindly cooperate with the team of ICT4SD 2024. And lastly, I would also want to thank our session chair, Dr. Kirit J. Modi, for chairing this session. Thank you so much, sir, for being a part of this session. A token of appreciation to the chair on the behalf of Team ICT4SD 2024 and Global Knowledge Research Foundation and partners. Thank you, sir, for your valuable presence.